Hey guys, Persistent Programmer over here, and today we're going to do another Leetcode question on crossed lines. Now, this is a dynamic programming question, and it may seem a little bit hard to understand at first, but stay with me here and we'll get through it. If you haven't subscribed already, go ahead and hit that subscribe button, and that will really help you understand and look at these types of problems, see the patterns, and solve them. Okay, the problem is asking us to find the maximum number of uncrossed lines that we can create given our input arrays A and B, and the lines cannot intersect, so that's one of the conditions. So let's solve this problem manually before looking at the dynamic programming solution. So here we can see that, okay, we have a match here, and if I move on to the 4, I also have a match here. And I'm not going to go back and check this previous element, because if I match 2 and 2, then that means that this will intersect, and we don't want that. So we want uncrossed lines. And let's look at another example here. So I can get my inputs in different sizes as the array length. So if I go 1 1, yes, I have a match, and then I don't have any other matches as I compare my numbers until here, and then I have another match. So in this case also we will return 2, and we don't need to do this other match with 5 and 5 because this will intersect this match with 1 and 1. So with that idea, let's go ahead and see how we can break this down into subproblems and solve those subproblems to get to our final answer. Okay, so if I give you two input arrays, 1 and 1, and I asked you to find how many uncrossed lines can you make, the answer is 1. So you can make 1 uncrossed lines here, right? So if I look at these two elements, and if they match, what I can do is I can just add 1 to my previous subproblem, which is 0, which is if I give you blank arrays, the answer would be 0. If I gave you nothing to compare and I said how many uncrossed lines could you create from this, the answer would be 0, right? So this is the answer of the first subproblem, which is if I give you empty inputs. Now, if I give you two inputs that are equal, the answer would be the answer of the previous subproblem plus 1. So 0 plus 1 is 1. So that is how you would solve one subproblem. Now, let's go ahead and look at this entire table. I've taken the first example here, and let's begin to populate all the subproblems and see how we can get to the solution. Okay, so I've put my 1 there in the first spot. Now, what if I told you, okay, I'm going to add a 4 to the first input. So let's say now A is equal to 1 and 4, and B is still equal to 1. Right, so how many lines can you draw at this point? Well, you can still draw only one line, right? So what I can do from using this table is take my max at this position, at my column -1 and my row -1. So up here and over here. So if I take the max of these two, I will be able to see which gives me the higher value to put in this spot. So at each point, we need to make a decision. What is the maximum number of uncrossed lines I can draw? What is my reach to my element that I can use to derive this solution, right? So I can only reach to the column -1 and row -1, and from this deduction, I can tell, okay, is my max higher or not, right? So for this position, it will still be 1, because if I add a 4, it doesn't matter for the solution at this position, because 4 doesn't match 1, right? Then I come to 2. I'm adding a 2 to the A matrix. And when I'm at this 2, 2 and 1 also don't match. So what do I do again? I just take my max of my previous answers and I just put a 1 here. So this is how we build on our final answer. Like, what is this position, right? So this position gives me the full numbers of uncrossed lines that can be created from these two arrays, 1, 4, 2 and 1, 2, 4. And that is the whole idea. So at each point when we're building this matrix, we are truncating what our inputs are and finding an answer to that subproblem, which will help us find the final answer, which is what is the number of uncrossed lines that you can draw from these two inputs. And this is the same problem as the LCS problem, which is a very popular dynamic programming question. And don't get me wrong, like when I read this problem, I did not see the connection either. But with more understanding and more research, I was able to figure out, yeah, it's basically the same problem. They just gave you numbers and asked you to cross lines. And we're solving the same subproblems here to get to our final solution, which is to figure out, given these inputs, what are my most lines that I can draw from each of the arrays without crossing and going back. So now we're at 2 and we're comparing with this 1. So let's write it out to be clear. So currently we are comparing where A is 1 and where B is 1 and 2. And what's my reach here? My reach is still 1, right? So I'm going to put a 1 here. And I find this again by getting my max from column -1 and row -1. Okay, next time at 4. So there is another element added to A here, so which is 4. And does this do anything to my my total max number of uncrossed lines? It doesn't, because 2 doesn't equal 4, right? So we'll do the same thing. We'll get our max from the left and above, and we will put a 1 here. Okay, now we have a match. So at this point, we have a match where we have a 2 here, and we also have a 2 at our next spot, right? So these two match. And what we can see is that, okay, well, we have a match and we need to do something to this matrix to represent that. And what do? We take the previous answer that we got and we add 1 to it. So we add 1 to this cell here and we get our result as 2. And why are we adding 1 to this cell here? Because remember, this is the subproblem that tells us that, okay, what would be our result if we didn't add this value here, right? So if we didn't consider this value and if we just chopped off the matrix without this value, right, our sum would be 1. And if we include this matrix, so that's what we're doing at each step in the dynamic programming table, we're just deciding what is my value at this position if I include this value, right? So that's how we get the 2 here. Okay, awesome. So do you see that if I took this subproblem and I had the same values here, right? 1, 2, and if I was given this input as A and this input as B, right, I would get my answer at the same spot. And that's because this will work for each subproblem, adding up to the full problem. The same way it worked just when our input was just 1 and 1. So that is the whole idea behind solving this problem. Okay, great. So now I'm at this position at 4. So what does it look like right now in my matrix? So I have A as 1, I'm comparing to 1, and B is 1, 2, and 4, right? So if I had this combination of elements, what would be my number of uncrossed lines I could draw? It could only be 1, right? So by doing this, by looking left and up, we get our 1 here. And then we come to the next spot. And what does it mean to come to the next spot? That means we have included one more item. So we have included this 4 in our A. And looking at this, well, we can see that, yeah, like we have a possibility to get another element here, right? This 4 and 4. So what do? We add 1 to our previous answer, to our previous subproblem. So what this is saying is that if I include this 4 at this position, what value I will get is this answer. So it's 1 plus the answer to the previous subproblem. So I will add 1 to that and I will get a 2 here. And then I'm at my final spot here. And what does this spot entail? So this spot entails when we have all our elements, right? So 1, 4, 2 here, right? So now you see that if we were to count this again, it would be a crossed element, and we are not going to do that because what we do is we take the max of, again, this element, and this gives us just a 2, and that's our answer here, right here. And using the properties of dynamic programming, it already doesn't count the same elements twice, right? So using this dynamic programming table, we're able to achieve our answer by looking at each subproblem and checking if we can reach that position or not. I hope this helps you understand this problem a little bit better. And to analyze our time and space complexity, so our time complexity is going to be m times n, where m is the length, the row length, and n is column length. And same thing for space because we are creating an additional structure of the same size. So to review our solution, what we're doing is we're just initializing a matrix with 0 in our first row and column, and this is to take care of all the edge cases if we're given like an empty A list or an empty B list. So it will take care of all those cases because it will just return 0. Like even if I had one element here and this was empty, it would just return 0 because you can't draw an uncrossed line, right, with just one element. And then what we did is we added 1 to our previous subproblem, the answer to our previous subproblem, and that's how we got the answer to this position. And lastly, what we did is we took the max to check if our above row or above column gave us a better answer, a higher answer, if we included that value. And that's all we're checking. We're checking the combinations of different chunks of the A and the B to get to our final answer. Okay, awesome. So if all of this makes sense, let's look at the code. Awesome. So I'm back in Leetcode, and the first thing I've done is initialized my DP matrix MTX, and I've created a 2D array to store and fill the values. So it's just 0 right now. So let's do a quick print to show you guys what this empty matrix looks like. And I've also created a video just explaining in my new series, PyBytes, how to create this 2D matrix in Python and fill them with zeros. So I will put the link in the description. Go ahead and check that out. Okay, so the empty matrix look like this, and I've just filled them with zeros here. So I've done that using List Comprehension. And if you're not familiar, just go and watch that video and it will help you understand how this is done in one line in Python, which is awesome. Okay, so getting started, what we want to do is we want to iterate over this DP matrix and populate our values the same way we were doing manually. So what I'm going to do is I will start with the rows. So for R in range, I will say starts at 1 and goes up to len A. So we're considering the input A as the rows. So that's the input we had in top on our table. So for R, and then for C in range 1 to len B. So capital B, okay? And what we want to do here is we want to go through two major cases. So if the numbers match, then what we want to do is add 1 to that value. And if they don't match, we want to take the maximum from the left end above us. So let's first go ahead with the first case, which is if the values match. So to check if the values match, we want to access that same position in um, the list A's matrix. So what I'm going to do here is say R minus 1, C minus 1. And the reason I have this minus 1 is because our DP matrix is actually one more position than our A and B input matrix. And that's because we padded the top rows and top columns with 0 because that will handle the cases where we have an empty list as input. So that's why we need to go one backwards here to grab that element from A. Okay, and same thing with our B. So if our we want to check if our A row minus 1 is equal to our B column minus 1. So C is the index that corresponds to B. So that's what we're checking here. So if these values match, so we're just going one before in A, and then so this is up, and this is one less in C, so that's left. And we're matching those two values the same way we were doing manually in our matrix. So if they match, then what we want to do is update our matrix, our result matrix. So we'll say matrix row and column. So at that position, what we want to do is we will take our previous answer, so matrix R minus 1, C minus 1, and this is looking at diagonally upwards from that position as we saw in our solution, and then add 1 to that. So that's what we're going to do. And then else, if the numbers don't match, then we just take the max of our previous answers and put that in that spot. So we'll say matrix RC equals the max of matrix R minus 1. So this is the row above. R minus 1, and we want to stay in the same column. So we want to take this and to the left. So to the left we go mtx R, and we want to say C minus 1, column minus 1. Go to the left. Okay, awesome. And what we want to return now is return our last spot in the matrix. So to get the last spot in Python, we just go row minus 1 and column minus 1. So that's how we get that spot. And let's go ahead and print the matrix too, so we can visually see it and match the answers with their manual values. So, okay, so we have this and looks okay. Let me go ahead and run code. Hopefully no errors. Okay, so something happened. Our last spot didn't get populated, and okay, this happened because I actually forgot to go one more position forward in our DP matrix, because remember we're checking from 1, so we need to go one more position over. So let's give this a try and see if this works. Okay, yeah, so we got the same values that we got manually. Awesome, so I'll go ahead and submit code. Great, accepted. Thanks guys. If you like this video, please go ahead and subscribe to the channel, give this video a like, and if you have a different solution, please post it in the comments below. It could be in any other language. It's just gonna help other people look at the solutions and understand and solve this problem themselves. Thanks guys, happy coding!